Have you ever stopped and wondered what makes everything, well, tick? Today, we're going to pull back the curtain and explore 10 awesome physics superpowers. These are the rules that run everything, from a simple baseball toss to the stars lighting up the night sky. Let's jump right in. So, are you ready to feel like a superhero? Because we're about to unlock the secret codes that run the entire universe. Think of this as our own physics adventure. First off, what even are these physics superpowers? Well, let me tell you, physics isn't just some boring stuff you find in textbooks. Nope, it's a set of incredible invisible forces at work all around us every single day in everything we do. So where do we begin? Let's kick things off with the big rules of motion. This is all about how things get going and, just as important, how they stop. All right, first up is a big one. It's a force you're feeling right now. You guessed it, gravity. You know, gravity is this amazing, constant, invisible pull. It's what keeps your feet planted firmly on the ground instead of floating away. It holds entire oceans in place, and it's the reason the moon hangs around us every night. Seriously, without gravity, we'd all just be drifting off into space. Okay, next on our list is a superpower that's, well, a little bit lazy. It explains why things just want to keep doing whatever they're already doing. It's called inertia. Have you ever been in a car when someone hits the brakes really hard and you kind of lurch forward? Yep, that's inertia in action. It's all thanks to Newton's first law. Basically, objects in motion want to stay in motion, and things that are just sitting still, well, they want to stay still. It's that simple. So, if things like to stay put or keep moving, what does it take to change that? Well, you need a push or a pull. And that brings us to our next dynamic duo, force and speed. Think about it like this. It's way easier to push a tiny toy car and make it go super fast than it is to push a real heavy car, right? That's Newton's second law in a nutshell. The more force you use, the faster something gets going. It's a direct link. More push means more vroom. And for our final big rule of motion, we've got one that explains everything from how a rocket launches into space to why jumping on a trampoline is so much fun. Get ready for action and reaction. Oh man, this one is one of my absolute favorites. It's Newton's third law, and it's so cool. For every single action, there's an equal and opposite reaction. Think about a rocket. It pushes all that hot gas down, that's the action. And what's the reaction? The rocket blasts up into space. How cool is that? All right, we've tackled the big rules of motion. But what about those forces that feel, well, a little like magic? Let's dive into some powerful, invisible forces you can feel every day, even if you can't see them. Okay, first in this category is a hidden helper you literally use with every step you take. What is it? It's friction. So friction is the force that kicks in whenever two surfaces rub against each other. It's the reason your shoes can grip the floor so you don't just slip and slide all over the place. It's why you can hold on to a baseball bat, or why brakes on a bike work. It's a super important force that slows things down. And you can really feel the difference, right? On something smooth like ice, there's very low friction, which is why it's so slippery and easy to slide on. But on a really rough surface, like sandpaper, there's a ton of friction, making it way harder to move things across it. All right, our next invisible force really feels like magic, even though it's pure science. Let's talk about magnetism. So how do magnets work? Well, they create these invisible force fields around them. And these fields are strong enough to pull on certain types of metal without even touching them. It's the science magic that holds your drawings up on the fridge, and it's even used in some super fast trains. Okay, for our final section, we're zooming out to look at the big picture. We're talking about the very stuff that makes up everything in the universe and the amazing energy that powers it all. Let's start with light. Did you know it's the fastest thing in the entire universe? Nothing's faster. And when you look at a mirror, what you're seeing is that light bouncing off the shiny surface and right back into your eyes. That cool bounce is called reflection. So we've talked about forces and energy, but what is everything actually made of? The answer is matter. And pretty much all the matter you see every day comes in three main states, or forms. First, you've got your solids, like a block of ice. It just holds its own shape, right? Then you've got liquids, like the water you drink, which just flows and takes the shape of its container. And finally, you've got gas, like steam, which spreads out to fill any space it's in. And the craziest part? It can all be the same stuff, just with different amounts of energy. And speaking of energy, this brings us to one of the most important rules in all of physics. Energy can't be created and it can't be destroyed. It just changes costumes. It transforms. Take a look at this. The energy you use from your muscles to pedal a bike can be transformed into electrical energy, which then transforms into light energy to power a light bulb. It's all connected. And how does that electricity work? Well, it needs to flow in a complete loop, kind of like a racetrack. We call that a circuit. When the path is closed, the energy can flow all the way around, and boom, the light turns on. A light switch, it's just a simple gate that opens or closes that path, either letting the energy flow or stopping it. So, after all that, what's the big takeaway? It's that your world is built on physics. You're basically a scientist every single day, using these superpowers without even thinking about it. I mean, just think about it. When you're jumping, that's gravity and action-reaction. When you're playing, that's force and inertia. Riding your bike, that's energy transformation. Turning on a light, you're completing a circuit. Walking, sliding, it's all physics. So that leaves us with one final challenge for you. As you go about your day, just look around and ask yourself, what physics is happening right here, right now? Keep asking questions and stay curious.